Let's talk about t-distribution. We learned when we have large sample size and we know the population standard deviation sigma, we can get the critical z-value to build the confidence interval for the p-hat sample proportion. However, when we have small sample size and we don't know the population standard deviation, we use t-distribution. So in the formula for the critical t-value, this S is sample standard deviation. We can get critical value based on the z-table and t-table. In Excel, we have functions t dot inverse for the critical t-value and norm dot S dot inverse for the critical z-value. The probability you use half alpha, the area, then you have to put a negative because you will get the negative number. So negative, negative, then you get the positive. So that's the critical t-value. Or you can 1 minus half alpha, then degree of the freedom, sample size n minus 1. Similarly, for the norm.s inverse this function, if you use the half alpha, the area for the probability, you have to put a negative. So negative, negative, you get a positive answer. Or you can just use 1 minus half alpha. Here, we run the Python code for the t-distribution. You see, this middle part is a confidence level. It's 1 minus alpha. So total area is 1. So this both tails together alpha. So half alpha here, half alpha, the right side tail. And for the Excel, no matter t-distribution or normal distribution for these two functions, the probability here means if you use this left side area, then you will get this value. If you want to get this point, you have to use the left side area to this variable. So total 1, the area 1 minus this right side, the tail, you would get this left side area to this point. So if you only use half alpha, you will get a negative. You use 1 minus this half alpha, that means this left side area, and you get a positive. You see these both symmetric. And we have the margin of error formulas. So for the t-distribution, you use S, sample standard deviation. Here is the population standard deviation. Then we could get the confidence interval. So for the t-distribution, the point estimate x bar sample mean minus margin of error is the lower bound plus margin of error is the upper bound. Here is p hat is sample proportion minus this margin of error lower bound, upper bound. Besides, we are able to get the needed sample size. Both formulas we use a critical z-value. If the sample standard deviation is given, you use the top formula. If you know the sample proportion p hat, you use the bottom formula. So in a word, confidence intervals are constructed around a point estimate, x bar, sample mean, p hat, sample proportion, using statistical table, z-table, t-table, or we could use a calculator, TI-8384, or use functions in Excel. Now let's see some examples. So the first one, confidence level 99%, we know that one tail is 1 minus 0.99 divided by 2. So here, you can use negative, then use this function, then you use directly just half alpha, or if you don't put the negative, here you need to change 1 minus 0.005, that means 0.995, then degree of freedom, so n minus 1. The second question, so we have the formula for the margin of error. First you get the critical t-value, then you could get the margin of error. The third question, we have the formula for the lower bound, upper bound, the confidence interval. So you get a critical t-value, get a margin of error, then sample mean minus the margin of error, you will get the lower bound and then upper bound. Number 4 is same type of question as the first question. I hope this is helpful.